Alright, hello everyone. Today I'll be going over my solution to USACO 2019 February Contest Silver. Problem number 3, the Great Revegetation. So, a lengthy drought has left Farmer John's end pastures devoid of grass. However, with the rainy season arriving soon, the time has come to revegetate. In Farmer John's shed, he has 2 buckets, each with a different type of grass seed. He wants to plant grass in each of his end pastures, choosing exactly one type of grass to plant in each. Being a dairy farmer, Farmer John wants to make sure he manages the somewhat particular dietary needs of his M cows. Each of his M cows have 2 favorite pastures. Some of his cows have a dietary restriction that they should only eat one type of grass consistently. Farmer John therefore wants to make sure the same type of grass is planted in the 2 favorite fields of any such cow. Other cows have a very different dietary restriction, requiring them to eat different types of grass. For those cows, Farmer John, of course, wants to make sure their 2 favorite fields contain different grass types. Please help Farmer John determine the number of different ways he can plant grass in his end pastures. Okay, so let me model this problem in a graph. So there are 3 farms, Farm 1, Farm 2, and Farm 3. I'll label them like so. Now what the problem is saying that the seed types for 1 and 2 have to be the same, and then the seed type for 3 and 2 have to be different. Now here I'm going to create edges to represent that. So 1 and 2 are the same, and then 2 and 3 different. Now let's think of the case where farm 1 is seed type 1. And that will mean that farm 2 is also seed type 1. And farm 3 would all have to be 0 because it's different from 1. Now, there are 2 cases where this solution would work. It would either be this case, or it would be the case where 1 is instead of 1 it's 0, and then this would also be 0, and this would be 1. Now what you realize after doing a lot of test cases is that for every connected component, there are 2 possible cases. So let me show you an example of what this could look like. So let's say that there are some farms here, okay? And there's connections like that. And then let's just say that this farm has no connections. Or no, I guess it has to have connections, so let's just make another one. Okay, so regardless of whether these connections are S or D, what you have to realize is that for each of these connected components, so this one, and this one, there are 2 cases. Because let's say that let's just make something up, DNS. Well, this will be 1, this will be 0, and then this would also be 0. But there's always another case where each of these are the opposite. So this is 0, 1, and 1. So after doing some more of those, you realize that the number of connected components is very crucial to the solution. And the solution is 2 to the power of the number of connected components. This is because there are 2 cases for every connected component. So you would multiply the number of possibilities by 2 each time. So it would be 1 times 2 times 2 times 2, which is 2 to the 3rd. And 3 is the number of components, or connected components. Now let me model this in code and show you what it looks like. Okay, so here I created basically all the inputs and the arrays that I'm going to use. And so what you'll realize is that you don't really need A, because regardless of whether it's S or D, these connections all remain the same. So we don't need to really differentiate them, so you'll see that I don't use it here. So ADJ is our adjacency list, a visited array, so that we don't have any repetitions. So what we're going to do is we're going to create a string called output, and then we're going to make that 1. Why 1? That's because when we have 2 to the power of the number of components, we're guaranteeing that in binary the start of the start of the output will always be 1. This is because whenever we multiply by 2, we're adding another 0 into our solution. So what this means is that if there's 4 solutions, it would be 1, 0. If there are 8, it would be 1, 0, 0, 16, 1, 1, 0, 0, 0. You get the point. And because it's 2 to the number of components, we're guaranteeing that it's 1 is at the beginning, and then all the rest will be zeros. So that's why output defaults as 1. And what we're going to do is iterate through all the different forms. And then we're going to, if it hasn't been visited yet, we're going to DFS them. So if visited, we're going to continue. And then if not, it means that it's a new component. And so we can output, we can add another 0 to output. And then let me create a function called DFS. This will just be our DFS function. So current cow. And okay, so this is some really bare bones DFS, but it's really all we need. So this checks to make sure that we don't have any repeats, and then we're going to iterate through all the different edges for each node. And then what you'll realize is that for each of the connected components, it will a 0 will get added to the output, and we can just output the output. And that should get us the answer. Now, one thing to note is that the reason we can't use a long or an int to represent the output is because when we have 2 to the power of the number of components, the number of components could be upwards of n, which means that it could be 2 to the power of n. And we know that n could be up to 10 to the 5th, so that would mean 2 to the 10 to the 5th. Which is quite outside the borders of what a 64-bit number can do. And that's why in order to get full points for all of the test cases, you have to make sure to use a string to represent your output instead of a number. And that should cover it all for today. Thank you for watching. If you have any questions or concerns, please let me know. I'll leave my email below, so if you have any questions, you can let me know through there. And thanks. Bye.